Hi, welcome back. In this video, we're going to get a new differentiation rule or formula for the derivative of a general exponential function. A general exponential function is a function like 2 to the x, 3 to the x, 1/2 to the x, where the base is any positive number except 1. And the only one we know how to do so far is e to the x, the natural exponential function. So we're going to use that one plus the chain rule to derive a new formula for all other exponential functions. So let's kind of review what we know about the chain rule and the natural exponential functions. So let's do an example. Suppose we want to differentiate y equals e to the x squared. That's a composite where the outside function is the natural exponential e to the u, but the inside function is a function of x squared. To use the chain rule on this, remember we differentiate the outside with respect to u, so it's just e to the u, and we multiply it by the derivative of u with respect to x. So in our case, we turn out to get e to the x squared times 2x. And I can rewrite it as 2x e to the x squared. So what we used was a formula for a composite where the outside function is the natural exponential. So in general, for a natural exponential function of the form e to the u, the derivative with respect to x of e to the u is always e to the u times du dx. Okay, so this is what we're going to use to get a formula for all exponential functions. So general exponential functions, remember, look like this. A general exponential function has the form y equals b to the x, where b is some positive number but not 1. So let's look at how we can use this formula for the natural exponential function to get a formula for a general exponential function. So suppose we have a function b to the x. What we want to do is rewrite that in terms of a natural exponential function. So the first thing I can do is I can rewrite the number b as e to the natural log of b. Remember, the natural exponential function and the natural logarithmic function are inverses of each other, so they undo each other. So e to the natural log of something is just something. So that's the number b, and we're raising it to the x. Now, using the properties of exponents, I have a number raised to a power, and that's raised to another power. Well, all we have to do is multiply the exponents. So I'm going to rewrite it now as e to the natural log of b times x, the natural log of b times x. That's the new exponent. So now what we have is the natural exponential function with an inside function. So the inside is just natural log of b times x. So let's use the chain rule on that to get the derivative of b to the x. So the derivative of b to the x is going to be the derivative with respect to x of e to the natural log of b times x. And using the formula we have in the box up there, this is going to be the derivative of the outside with respect to the inside. Well, the derivative of e to the u is e to the u, but we're going to multiply by the derivative of the inside. So we need the derivative of natural log of b times x. Well, the natural log of b is just a constant. So what's the derivative of a constant times x? It's just the constant. So what we get is e to the natural log of b times x times the natural log of b. And remember, e to the natural log of b times x was just b to the x. So in the end, we get the following formula for the derivative of b to the x. We get b to the x times the natural log of b. So for example, if I want to differentiate 2 to the x, the derivative is just 2 to the x times the natural log of 2. That's it. All right, so we'll be using this formula for the rest of the semester, so we're going to add it to our toolbox. And I'll see you in the next video.